Okay, welcome to section 7.2. This is solving a system of linear equations graphically. So graphically is just a way of saying by graphing, by making graphs. Okay, so as we learned in lesson 7.1, the solution to a system of linear equations are the numbers that work in both equations. So similarly, if the two linear equations are graphed, the solution will be the point that belongs to both lines, which is also called the intersection point or the meeting point. So here's our first example. Determine the equation for each of the lines shown in the diagram at right. So we're going to use our skills from chapter 6 to do that. And then B, what are the coordinates of the solution or intersection point? So our equation, there's a few different formats or forms of equations that we studied in chapter 6. I think the easiest and most common one is slope-intercept form. So if we can find the m value and the b value for each line, we should be able to come up with two equations fairly easily. So I'm going to call this line equation A and this one equation or line B. So for the red line here, we know that it has a y-intercept or a b value of 5. And the slope is, it seems to go up 1 over 1, up 1 over 1. So the slope is 1. So if I put that in y equals mx plus b form, I get y equals 1x plus 5, which I just simply write as y equals x plus 5. So there's one of my equations. For line B, that one that's going down as we go to the right, it has a y-intercept of 1, and it has a slope of negative 1 over 1. In other words, negative 1. So y equals negative 1 x plus 1, or y equals negative x plus 1. So there is our second equation. What are the coordinates of the solution or intersection? Well, the solution is this point right here. So its coordinates are, it's at negative 2, 3. The negative 2 is x coordinate and the 3 is the y coordinate. So explain why they are solutions to the system. So what we're going to do is check it in both equations. Remember, that was equation A and this was equation B. So when I check it in A, I'm checking y equals x plus 5. So in the spot of the y, I put the 3. In the spot of the x, I put the negative 2. And then I simplify each side as far as I can. And I end up with 3 is equal to 3, which is true. So this one checks out. I'm going to put a little check mark there to show, yep, it worked out for equation A. Let's check it in equation B. So y equals negative x plus 1. And so the y coordinate is 3. The x coordinate is negative 2. So just be careful. You're substituting in a negative, and you already have a negative in there. So you have two negatives involved. Negative negative 2, or the negative of negative 2, is 2. A negative times a negative is a positive, in other words. And I end up with 3 is equal to 3. So it works for both solutions, or both equations, pardon me. So since negative 2, 3 checks out in both equations, it is the solution to the system. Okay, so that was one where the graph was given. So it's fairly easy to see the solution. It was just our intersection point. Here's another typical kind of question where you're given two equations. You have to graph them and then find the intersection point. So we've got two equations here. Of course, we could once again call them equation A and B if we want to. So I'm going to go ahead and label them that, just so once we draw our lines, we can label our lines. So this one, it's not in y equals mx plus b form. So first I'm going to start by rewriting equation A. So it starts off as x plus y equals 8, but I want it in that y equals mx plus b form. So I'm going to subtract x from each side. So that leaves me with negative x plus 8. So that tells me that the slope is -1 and the y-intercept is 8. So I'm going to start at 8. So my y-intercept and my slope is -1/1. So every time I go down 1, I go over 1. So that eventually will take me down to this. And so I'm going to go ahead and draw that line here. And I'm going to put arrows on it because it goes on forever. So again, that's just using skills from chapter 6. So there's one of our lines, and that was line A. I'm going to switch to blue. I'm going to rewrite equation B. It's currently not in y equals mx plus b form, so I'm going to change that. Divide everything by -2. So notice that negative divided by negative became +3/2, and a positive 14 divided by -2 became -7. So my y-intercept is -7, and my slope is 3/2. So I'm going to go up 3 and over 2, up 3 and over 2, up 3 and over 2. Yeah, just making sure I got that right. -7, 1, 2, 3 over 1, 2, 3 over 1, 2, 3. Oh, I only went over 1 there. Over 2 would have been there. That was the problem. Okay, and we'll keep going. Up 3 over 2, up 3 over 2. Okay, so there's my blue line. And I'm going to label that one with a B just to stay consistent. That way, like I'm working in 2 colors, but I know most of the time you're working in pencil, you're working in 1 color. So you want to use A's and B's or something to label them. So our solution is right here. So our solution is the intersection point, which appears to be 1, 2, 3, 4, 5, 6, 2. Okay, so that's our answer. But now, so first we did solve it, but now we have to verify, which means we have to check. Okay, so we're going to check our answer. So I'm going to check 6, 2 in A. So x plus y is equal to 8. And the x value is 6 and the y value is 2. And 8 is equal to 8. So it checks out for equation A. Now we're going to check 6, 2 in equation B. So that's 3x minus 2y equals 14. So 3 times 6 minus 2 times 2. Is that equal to 14? So I get 18 minus 4. Is that equal to 14? And yes, 14 is equal to 14. So it works in both. So now I'm 100% sure my solution is correct. B, solve the following system of linear equations by graphing, then verify your answer. So very similar to the one that we just did. So let's try this one, and then we'll go on to our last bit here. Okay, so once again, I'm going to label these as equations A and B. And I'm going to rewrite A into y equals mx plus b form. So I'm going to subtract 2x from each side. Then I'm going to divide each side by 3. So I get a y-intercept of 1 and a slope of -2/3. So here's my y-intercept of 1. And then my slope of -2/3 means I'm going down 2 and over 3, down 2 and over 3, down 2 and over 3, etc. If I want to work backward, just to use up as much of the graph as possible here, I'm going to extend that direction. And we're going to go ahead and graph this. So there is our first equation graphed. I'm going to label that with an A and make sure it has arrows on it. I'm going to go ahead and rewrite equation B. So x minus y is equal to 4. So negative y is equal to negative x plus 4. Divide each side by negative 1. And I get y is equal to x minus 4. So my b value is negative 4 and my slope is 1. So my b value is negative 4 means it's here. Then my rise over run is 1 over 1. Oh, and I can see right where we overlapped right there. So that's going to be my solution. I'm going to go ahead and draw my line. I got lots of points there now. So there we have line B. And here's our solution. And that is at 3, negative 1. Now I have to check that. So we've done the solve part, but now we need to verify. And I'm just going to do it up here because I'm kind of running out of space there. So I'm going to check 3, negative 1 in equation A. So 2x plus 3y equals 3. So 2 times 3 plus 3 times negative 1 equals 3. So 6 plus negative 3 equals 3, or 6 minus 3 is 3, so it works out in A. Let's check 3, negative 1 in B. This is the simpler equation. X minus y is equal to 4. So 3 minus negative 1, is that equal to 4? And the double negative here becomes a positive. So I do get 4 is equal to 4. So it's now been verified. So it does work out. So that is our solution. So if you're circling your final answer, that's actually your solution, 3, negative 1. Okay, here's our final example. Example 3, solving a word problem by writing and then graphing the linear system. So this one's a little bit different because we're not given the equations. So we're going to come up with them using our skills that we practiced in 7.1 to write some equations. So A, write a linear system, that means 2 equations to model this situation. Okay. So to visit the Head Smashed in Buffalo Jump Interpretive Center near Fort Macleod, Alberta, the admission fee is $5 for a student and $9 for an adult. In 1 hour, 32 people entered the center and a total of $180 in admission fees was collected. So we're going to come up with a system, which means 2 equations. And I think that one thing that we can do is assign some variables. So basically, what's our x and y going to be in this scenario? Well, I think instead of using an x and a y, we'll probably use an A and an S for adult and student. Those are our 2 variables. So we're going to let S equal the number of students, and we're going to let A equal the number of adults. Okay, now we know 2 totals. So one of our totals is that 32 people came in, and the other one is that $180 in admission fees was collected. So we're going to make an equation out of each of those. So we know that 32 people means that adults plus students was equal to 32. Write that by that part. And we also know that $9 times every adult plus $5 times every student equaled $180 total. So we have to decide when we graph this. So there's our system. We got 2 equations. We're on to part B now, where we're going to graph them and then solve it. We need to decide which of these variables we're going to put on which axis. And so I'm going to draw a few lines here to emphasize our axes. And I'm going to choose to put A on the y-axis and S on the x-axis. And it doesn't really matter which one you put where, but that's just what I'm going to choose, unless it specifically tells you to put something specific somewhere, then it doesn't matter. Just going to move myself. Okay, first time I've tried that, so hopefully that works. So we have adults, which is A. Oops, sorry. on the y-axis and students, which is S, on the x-axis. So I'm also going to label that. Actually, I'll type it and then I can swing it around. So number of adults is here. And the number of students is here. So we've got a label on each one. We've also labeled the X and Y, relabeled them as S and A, respectively. Okay, so I'm going to rewrite my equations into y equals mx plus b form, or actually, because I'm using A's and S's this time, so normally we're thinking y equals mx plus b, but this time we're going to be thinking A equals ms plus b for these equations, or for this system. Okay, so I'm going to start by rewriting. I'll call this one equation 1 and this one equation 2. So I'm going to rewrite equation 1 in that form. So I have a plus s equals 32. I'm going to say a equals negative s plus 32. So that is our first equation. And then I'm going to rewrite, I'll change colors actually. So when I graph, you'll know which ones I'm graphing. I'm going to rewrite equation 2 in that same form. So I had 9a plus 5s equals 180. I want to get the a by itself. So I have 9a equals negative 5s plus 180. I'm going to divide each of those by 9. So I got a equals negative 5/9 s plus 20. Okay, so when I take a look at my grid here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think I'm 20 high and 20 across. So I have to, those somehow fit all the way to 32 and 20. So I'm going to actually go all the way up to 40. I think this will divide nice and make this 40 at the top. And every 5 squares then will be 10. There's 5 more. So there we are, 20, 30. There we go. So 2, 4, 6, 8, 10. So we're going up by 2s. 12, 14, 16, 18, 20. Looks good and goes all the way up to 40. I'm going to do the same thing along the bottom. That way I can very easily do my slope. Everything will be proportional. There's 10, 12, 14, 16, 18. There's 20, 30, and 40. All right, so I am getting close to being able to graph here. I'm going to graph the blue one first. So 32, a y-intercept of 32 would be there. And then from there, I have a slope of -1. So it's going down 1, which means I'm going to intersect at 32 over here as well. So I'm going to go ahead and draw that line. Now this time I'm not going to have arrows on it. It is just going to be a line, and I'm not going to go into the negatives. So it will be going from 32 to 32. All right, my line 2, which will be done in green, has an intercept of 20, and it goes down 5 and over 9. There's 1, and then down 5 and over 9. So it ends here. So there's my green line, and of course I'm going to draw it to make it more obvious, to connect its points. So there is my green line. So what we're interested in is the intersection. What's a little bit tough here is we're going to end up estimating somewhat, because the intersection does not fall on a perfect grid line point. Oops, a little bit off here. We're going right in here. So our solution, we have to estimate. So it looks like it is occurring at 2, 4, 6. And sorry, I'm just looking at my answer key over here too to make sure I set things up the same way. It's really hard to say. It could be at, it looks like it's between 26 and 28. So I'm going to say 27. 27 across. And then it looks like it's up 2.5 spots. So that would be 5 over here. If I went down to this point, it looks like it would be 27. So I'm going to say, I think it's 27 and 5, but I'm not sure. So the way that we need to verify if that's true or not is to check it. And here's why the checking is so important, because if you're not sure, let's say we guess 26 and 5 or something like that, then we might get some equations where the checks don't work out. And that is sometimes a good thing because that tells us that we had the wrong guess. So let's check 27 and 5 in equation 1. So that's A plus S equals 32. So the 27 was students and the 5 was adults. So it does work for the first one. So we might have got lucky with our guess there. Now let's check and see if it works in equation 2. So this time we have 9A plus 5 times S equals 180. So 9 times 5 plus 5 times 27. Does that total $180 in admission? Oh, so I have 9 times 5 is 45. 5 times 27 is 135. 135 plus 45. Hey, oh my gosh, we did guess it right. Perfect. Okay, so therefore we know that this is the solution, but we should write a sentence. It was asked as a word problem in sentences. The equations weren't given to us, so let's write a sentence. So there were 27 students and 5 adults. And that actually makes sense as an answer too. We're not getting negative numbers of students or adults. We're not getting half, like 27 and a half students. That wouldn't make sense. And it does kind of make sense that there's more students than adults. That's usually what happens on a field trip. All right, so that takes us to the end of section 7.2. So this was on solving our systems by graphing and oftentimes creating our own graphs to do that. In the future, we're going to look at 2 algebraic methods, substitution and elimination. So that's what's coming up in the rest of this unit. Thanks for tuning in, and we will see you next time.